9.1 Power series. So a power series are important for understanding the physical universe and how we can represent functions that represent the universe. So later, we're going to start talking about how to represent sine of x, e to the x, and all these weird functions that we use over and over and over as power series or what we'll call Taylor series. But for now, let's just start with basic power series. So like x squared and things like that. So we need to first define an infinite series. An infinite series is an expression of the form a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6 plus ... until a sub n, right, where n is an infinite amount of terms, so you have an infinite amount of numbers you're adding up. We can represent that like this. So let's first break down what this symbol means. So this symbol right here, this is capital sigma, which is a Greek letter, which we translate in math to sum. K equals 1 means that we're going to start at the first term. So a sub k. That means if I were to plug it in, it'd be k sub 1. K sub 2 would be the second term. And we're going to allow k to go to infinity. So k from 1 to infinity, where the numbers a sub 1 and a sub 2 are the terms of the series, and a sub n is the nth term. So again, this big symbol here just means you're going to add up things over and over and over again. The partial sum of a sequence is defined as a finite sum. So if I were to add up the first term, I would get a sub 1, because that would just be the first term. The sum of the first two terms would be a sub 1 plus a sub 2, and the sum of the first three terms would be a sub 1 plus a sub 2 plus a sub 3. Now, if I repeat that process over and over and over again, we can say the sum of the n amount of terms is going to be sigma from k equals 1 to n a sub k. So that means we're adding an n number of terms, so say 1,000, 10,000, whatever it is. If the sequence of the partial sums has a limit, and we call that s with this weird little symbol, so s with little tick marks on the sides, as n approaches infinity, so as you approach an infinite number of terms, we say that the series converges to the sum s, and we write the infinite sum, which we write with the sigma symbol, is equal to s, which is our sum. Otherwise, if it does not converge to a number, we say it diverges.